There was probably more changes between, I think was 1989 and 2001. I might be off on the 1989. But the 2001 probably had bigger changes than the 2021.
Mm.
There was some significant changes, but the 2001, there was substantial changes. In the last edition, probably the biggest single change is the emphasis on amino acids. In the 2001, they were mentioned, but the only two we talked about was lysine and methionine. It was very empirical.
All right, well, welcome everybody to this episode of the Dairy Podcast Show. I am your host for today, Gail Carpenter, the State Dairy Extension Specialist at Iowa State University. I'm joined today by Dr. Bill Weiss, Professor Emeritus of Dairy Cattle Nutrition at The Ohio State University. During his 35-year career at OSU, he conducted research in the areas of effects of minerals and vitamins on cow health, forage and feed evaluation, and methods to incorporate variability into ration formulation for dairy cattle, and has published more than 150 journal articles. He also had an extension appointment conducting numerous short courses on dairy cattle nutrition and wrote more than 450 proceedings and extension articles. He has won several American Dairy Science Association awards and was named a fellow of ADSA in 2015. He served on the 2001 Dairy NRC Committee and as co-chair of the 2021 NASM, formerly NRC Dairy Committee. Dr. Weiss earned his bachelor's and master's at Purdue and his Ph.D. at The Ohio State University. So we're really excited to have him on today, get to pick his brain a little bit. Maybe, I don't know, now that you're retired, can you say things that you weren't allowed to say before? Like, what's your...
One of the joys of being a tenured full professor is you have a lot of freedom to say things that other people can't. So, no, not much new, or I won't say much different than I would have said a couple years ago. But I can say Michigan now. Before I couldn't even use the word Michigan, but now I can say it. So
I'm a Michigan native, so it's good to know that we could use that word. Yeah.
I go to Michigan every year on golf vacation, so I actually love the state. So
fantastic place to go. Yeah, and I lived in Ohio for a couple of years, so and I did enjoy living there despite the fact that it was Ohio. So so I want to start by kind of talking maybe a little bit more generally. You were on the 2001 and the more recent NASM committees. Kind of a funny story. When I first started my PhD in 2012, it's when I first started hearing that they were going to update the NRC, and Barry Bradford was my PhD advisor, and I said, is it worth buying a copy of the 2001 for myself to use as a reference if they're just going to be updating it? And he was like, I think you have plenty of time.
Barry knew what he was talking about.
Yeah. So you got to serve on both. You were the co-chair of the most recent committee and have obviously put a lot of your life's work into that. What is that like, being in the room with all those super smart people, probably the best minds in dairy nutrition and dairy research? What was that experience like for you?
People need to know how much work really goes into these books, and
Mm.
it took us too long, but it's a tremendous effort, and everybody in that room also had day jobs, and this wasn't their only job. It's interesting. There was a fair amount of, I'm going to say arguments, but professional arguments where we disagree and hopefully come to a consensus, and we usually did. And we might not be perfect, but I think the consensus won't be as wrong as one opinion might be. And you learn stuff like I knew nothing about calves, so I read the calf chapter so many times. I'm not an expert, but I learned a lot. So talking to all these people they're all dairy nutritionists, but they all have different specialties. So you learn more or learn a lot of stuff outside of your particular area. So it's, like I said, it's a challenge. It's a lot of work, but it's also rewarding when you're done and you finally see that book. You say, boy, we did something.
Yeah.
Maximize profitability and herd health with early detection in animal health, reproduction, and feeding. The most advanced bolus technology and professional support from agricultural experts make this possible with SmaxTech, the health management system that future-proofs your dairy operation.
What do you think is the biggest thing we've learned, or maybe changed? I don't know if change is the right word, but what's the biggest thing we've learned between the 2001 NRC and the 2021 NASEM?
Well, if you go back through every one of these, and they started in right around World War II, I think in the early 1940s, just increased food supply for humans. And if you go through, and every one is, none of them have been what I would call revolutionary. They keep making improvements. There was probably more changes between, I think was 1989 and 2001. I might be off on the 1989, but the 2001 probably had bigger changes than the 2021. There was some significant changes, but the 2001, there was substantial changes. In the last edition, probably the biggest single change is the emphasis on amino acids. In the 2001, they were mentioned, but the only two we talked about was lysine and methionine. It was very empirical. So that's the biggest change, I think, is the protein in general, but the huge emphasis on amino acids. And that reflects the information, in 2001, and you're looking now at research that was published maybe up to 1999.
Yeah.
Wasn't that much. And then since that time, there's been just a plethora of amino acids. And you can't do anything if you don't have data. So that's
right.
Remember, there was a whole lot more amino acid data in the last 10 years or so.
Yeah. So on the other side, what do you think is the biggest gap that we still have? As we look forward to whenever the next edition comes out, what are we really going to be? What are the gaps that we still need to figure out, and what are we hopefully going to be able to answer by the time?
The amino acids still need work. I mean, this is the first chance, and if you really look at it, the best part of the amino acid, or I should say the most complete, is just milk protein. And, cows need amino acids for lots of other things. So that would be a big improvement, or that may be an improvement as we get to know like maintenance amino acid supplies and so on and so forth. I think there's going to be a bigger push to get what we have now is what's called a requirement model. If your cow makes 100 pounds of milk, this is the nutrients she needs.
Mm-hmm.
And the opposite of that, or not quite the opposite, but kind of the opposite, is a response model. It says, this is the diet I have. How much milk will that cow produce? And it sounds like it's almost the same, but it's really not. And there's I think it's going to be a push to response models. So people can look at that, and if there's adequate data, they may say, for example, it isn't worth feeding buffers because the response, this is the predicted response, this is the cost of the buffer, it's not worth it. Or they may turn around and say, well, this is going to be likely a very profitable response if I feed this amino acid or this mineral. So I think there's going to be a bigger emphasis on response. The other big area I think that's still quite confusing, and that's carbohydrates.
Mm-hmm.
Because there's so many factors, and it will always be confusing and always be complex. And right now that is actually quite empirical. It's not, it says there's a table in there. If you have this much forage fiber, these are the starch and total fibers we think will work. However, that's affected by, it gives a whole big list of things. And so I think quantifying those, or at least quantifying some of those. So again, people might pick there may be an optimal starch concentration for alfalfa diets or for corn silage diets based on milk fat and other things. So that I think the carbohydrates still need more work, especially on the quantification of responses to changes.
Yeah, it's really interesting because it feels like carbohydrates is the one that we've been focusing on the longest, right? Like Pete Van Soest and like their cattle eat forage, right? Like that's kind of when they're out in the wild, that's what they're eating. It feels like carbohydrates should be the one that we have figured out.
if it's an average diet, average particle size, everything average, we know what to do.
Yeah.
I think we do. But as you start saying, okay, now I throw wet, high moisture corn into the mix, or I have had to chop my corn silage fine because it was too dry.
Yeah.
These affect it. So these things that get away from the average.
Yep.
And
Yeah.
the other thing we're limited on, and again, it's because of the data, is most cows in the U.S. are fed corn silage and some alfalfa. But there's places where grass is the predominant forage. And with all these cover crops, that's going to change some things. And so these carbohydrate things, as we deviate from a heavy corn silage, alfalfa forage base to these other ones, that likely will change these things. And we just don't have a lot of data on those types of forage.
Yeah. I think we have a tendency to think about carbohydrates a lot of time chemically, right? We think about them as cellulose and hemicellulose and what the actual chemical structure is of that carbohydrate. But what the cow sees is going to be, there's physical differences too.
Exactly, very much so.
Yeah.
And that again, there was an attempt. I don't think it's going to work in the field, but that's my opinion. The people who came up with this may disagree, to incorporate physical size much more. And it has to go in, but I think we need better approaches than what we're currently doing. It's just not accurate enough over a wide enough range of diets or particle sizes.
Yeah, I agree with that. I think that physical size is one that is kind of easy to measure, but not really too, right? Like we're looking at particle length, but that doesn't look at the 3D structure of whatever we're looking at.
Yeah.
But I think we also have to think about things like buoyancy and chewability, and there's all sorts of, once you start looking at some of the physical aspects of forages or carbohydrates or whatever it is, like the list just kind of, you got to start somewhere, right? Particle size seems like a great place to start, but
And the other thing, we have to be able to measure these things.
right.
So like buoyancy has an effect, but there's got to be a way a lab can measure it reasonably easy. And so a lot of this stuff on carbohydrates, we just don't know what to measure that can be applied commercially.
Yeah.
We can do things in a research lab, but if they can't be taken out into the real world, people end up using constants. And then, is that any better than not using anything? And I'd say usually not. So.
Well, you talk about the average, and feeding to the average and kind of looking at the average. That kind of leads me into another topic that you've done a lot of work on, and that's feed variation. And I know that you and Dr. St. Pierre have done a lot of work together on this idea of feed variation. And this is something I've said in class as recently as a couple months ago, that cows really crave consistency. But some of your work has shown that maybe that dogma is not as clear cut as we think it is. Do you want to talk about that a little bit?
Yeah, this is the last real area of research I concentrated on. I'm wishing if I could do my career again, I'd probably start with this because it was so interesting because we knew so little. And what I heard the same thing you heard when I was taking classes, and I heard it again and again, and it might be right, but when you start saying, okay, what's the basis of that statement? Everybody said there's no data supporting, none, zero. And so Norman and I said, well, why don't we do some experiments to do this? And so we set up a bunch of experiments where, a typical nutrition experiment will have different concentrations of protein or NDF or something. And our experiments were, the treatments on average were all exactly the same on average. But then we'd apply different ways to get the day-to-day variation. One diet may change day to day, and another one would be constant day to day. And so the treatment wasn't the mean. It wasn't the mean concentration of protein or the mean NDF. It was the variation, the day-to-day variation. And we did studies with protein and fat, dry matter, NDF. I think that's it. And a few other people have started looking at this as well. And in general, we found virtually no effect. In other words, if we make diets as constant as we can, and that they will be more constant than a diet in the field, because we did stuff that a farmer could not do to keep things so consistent. And then we applied variation to the other treatment, and in some cases, extreme variation, probably much more than you'd see in the field. And at the end of the day, the production was the same. And these were shorter experiments, and that's a limitation. But if we look at intake and production and so on average, they're the same. There's more variation, more day variation in intake and milk, like we'd expect, but on average, everything canceled out. And we did one, to me, interesting experiment where we had consistent diet, and then we put water onto corn silage like it rained, if this was a bunker and it got wet. And we put a lot of water, and we changed the dry matter by 10 units. And then abruptly threw that into the diet. So there's no adaptation. It was just, here's the silage got wet because of rain, but it was fake rain. And what happens? And intake dropped, just dropped like everybody thought, and it stayed low for about a day. And then it started coming up. We only fed the wet stuff. Again, we're trying to mimic events. We only fed wet for 3 days, and then it went back to the control. And so intake was down for those 3 days, but then on the day following, when it goes back to the normal silage, intake exceeded the control. We always made sure cows never ran out of feed, which in the real world may not happen, but cows never ran out of feed. And so again, on average, they were down for a day or two, but then they gained it back, all of it back. And in fact, the treatment, a lot of people will say, okay, when you have a wet silage event, you adjust the diet to reflect the change in dry matter, which means you're going to feed more forage as fed to get the same amount of dry matter. And so that was one treatment. And the other treatment, we didn't do a thing. We just fed the same on that it was, even though now the dry matter, the percent forage dry matter would be less because it's wetter, but we didn't change a thing other than feeding a lot more feed. The best diet was that one. It was better than the control and better than the one we adjusted. And that needs to be repeated. You don't get too excited about one experiment, but I think a lot of the negative people see with these wet silages, cows just run out of feed. And we didn't want that to be what we were testing. So we knew when the silage were going to be wet, so we fed more, and then we kept feeding more for a few days. So in the field, it likely is negative, but I'm saying if you actually made sure you increased delivery rates, maybe we don't have to change a thing. So these type of experiments, I think, can add some, are important, because if we think variation is important, we're going to concentrate on that. And if we find out it's not very important, we should have been concentrating on something else. So that's why I think some of this stuff is just important to look at.
Yeah. Yeah. Do you think variation in management plays into that sometimes too, once you're out in the field, like access to feed and push-ups?
No question. Yeah. Like I said, and I can understand in the field if it rains and you might make an adjustment, but you might not increase delivery rates enough because it's you're just, and the bunk just gets empty. That's going to be detrimental. And we don't want to waste feed. So maybe they'd say, okay, now the silage is back to normal, so I'm going to reduce delivery rates. And what we found is you actually have to keep delivery rates high for a few days. Mm-hmm. And so it's always a compromise, but management, I think, can handle a lot of the variation effects. And the other thing I do want to point out that what we talk about is day-to-day variation. There's studies out there with variation within a feed bunk. Mm-hmm. In other words, a bad mix. That has been shown to be negative. And that's a different type of variation. So I'm saying you're feeding a very good mix, but the chemical or the nutrient composition of that may change day to day. So variation has lots of meanings. You got to think of what we're varying, and I want to be very specific. I'm only talking about day-to-day variation in a well-mixed, well-made TMR.
Yeah. So what you're talking about more would be, you mentioned the wet feed events, or, your feeder shows up hungover, things that maybe one day to the next are gonna occur, right? Just user error, whatever it is. As opposed to one end of the silage pile versus the other end of the silage pile having having difference in nutrient composition there. Yeah. So I know another thing that you've worked on kind of along those same lines with Norman has been sampling frequency and some of the best practices for sampling. So how do you, when you're looking at that silage pile, knowing that nutrient composition is probably going to change as you go through there, what's the best way? What are some best practices for sampling to make sure that we're capturing some of those changes in nutrients?
That was one of the questions that actually got Norman and me on this stuff. We were sitting at a bar actually, and we started talking, and that was a question: how often do you need to sample this stuff? And Norman had done a little work on this, but it was pretty theoretical. And we said, well, we need to do some work to actually see is your theory right? And what we found is one is a lot of the day-to-day variation is not, the silage really didn't change. It just you sampled differently. You know, if you might have got a few extra corn kernels one sample, then you got more stalk in the next. But the silage really didn't change. And that was one big thing, is that I think the industry adopted this pretty quickly, is the need to take two samples, not one, and two independent samples. You send them in, you take the average of the two, and that should help mitigate some of this sampling. So that I think has caught on quite a bit. Then the next question is, how often do things change? And corn silage, in a big study we did with like 50 farms across the U.S., it doesn't change that much. And so we'd say it's better to take two samples less frequently than one sample more frequently. You're going to be less likely to be wrong. And for corn silage, depending a little, this is on cost benefit, and the cost of an analysis and sampling it per cow is a lot less on 1,000 cow farm than a 100 cow farm, because it's a fixed cost. So we'd say on these bigger farms, you probably should be sampling corn silage every 2 to maybe 4 weeks, but always duplicate samples. And then if it looks like it's changed, and it needs to change in a lot of these macronutrients in fiber, starch, protein, it needs to change by at least 5%, not 5% units, but 5%. So if it was 10% protein, if it gets to 9 or 11, you might think of changing. If it stays within just a little bit, don't bother. Alfalfa changes a whole lot more over time, which makes sense. That if it makes a significant amount of the diet, that should probably be sampled weekly or by every other week. Always 2 samples again. And after you do this a while, you'll start seeing, okay, my corn isn't changing. So let's knock out a sample and maybe only do it 3 weeks. So some of this shit can be adjusted on the fly. Inclusion rate, if you're feeding 2 or 3 pounds of alfalfa, doesn't matter if it changes protein by 2 units. I'm going to say it has no effect on the cow. Don't waste your money on that. Take another sample of corn silage. So inclusion rate becomes important too. So
all right.
It is a complicated question, I'll just say that.
Yeah.
And if nothing else, the duplicate samples, I think, will be the biggest bang for the buck. And again, over time, you can say, well, these samples keep coming back about the same. That means you're a pretty good sampler. But, if they are really different, you should work on your sampling skills. And we've published a few things on guidelines on how to sample some of this stuff, the mechanics behind it and all. So
it's one of those things, again, that you think we should have figured out because it's pretty basic. It's something that I have undergrads do, nutritionists do, producers do, but there's a lot more. You can't just do it mindlessly, right? There's steps to making sure you do it right. Yeah.
Toward the end of my career, when we were doing what started this whole thing, or one thing is a grad student was doing an experiment on fiber, and she's taking samples, and she comes in. I remember, and the corn side, I can't remember the numbers, but it had been running like 40% NDF. This was an NDF experiment. She come running in and said the silage now is 46% NDF or something, which would mean she has to reformulate everything. And I just sat there and said, okay. And I asked her the question. She said, why would it have changed? It's the same field, same day, everything was hard. And why would it have changed? He sat there and said, I don't know. And I said, well, I don't know either. So let's go sample it again. And that's after that event, I went to always duplicate samples every time because it was just a bad sample. And we would have made a change which would have screwed up the experiment, but could also have screwed up the cows. So
Yeah.
with duplicate samples, you're less likely to make a mistake. I won't say you're not going to make a mistake. You're less likely to make one, and the mistake likely will be less severe than with a single sample.
We spent a little bit of time talking. You mentioned that the variation was kind of more end of career thing for you. I'd be remiss if I had you on this recording and didn't ask you anything about minerals. That's kind of what you're known for. You've done so much in this area in your career, right? So what do you think from the 35 years that you were at Ohio State? What's the biggest shift that you've seen in our understanding of mineral nutrition?
Well, we clearly have better defined the requirements. They're getting closer and closer to the real ones. They're never going to be perfect, but we're getting better on most minerals. Some we've made no progress at all. So we can, if there's uncertainty with the requirements, it means you got to feed above requirement. And the more uncertainty, generally, it means the more above requirement. And people need to remember, excess has uncertainty too, and they have significant issues. So we don't want to just keep throwing mineral into this to cover uncertainty. So we're better at we've got better estimates of requirements for most minerals. I think in general the industry has toned down the over supplementation because of this. Most minerals still should be over supplemented above NASEM requirements because of uncertainty. But when I started, I'd see copper at 3 times requirement, zinc 2 to 4 times requirement, phosphorus at 1.5 times requirement. So these grossly overfeedings, and I still see it, or did see it, but to much lesser degree. So I think that's a big change. There's a lot more commercial mineral sources now than there were 35 years ago. And so that's one of the more difficult questions is how much, if you feed companies X mineral, what does that do to how much you should feed? And that's still a tough question. And how do you compare companies' organic mineral to companies A to company B? And that's still a difficult question.
What do you think is the biggest bottleneck to improving our methodology when it comes to understanding bioavailabilities?
It's one people need to know on minerals. It is not, you don't just measure what goes in one end and what comes out the other. If it was that simple, we'd have all the answers.
Yeah.
But, cows can absorb a mineral and then they use feces as the excretory route. If there's too much, they dump it right back out. But the mineral is available, just the cow didn't need it. And so that's a difficulty here because we want to evaluate the diet, not the overfeed. If we overfeed calcium, for example, the absorption goes down. But the diet is still good. It's just the cow didn't need it. So it's tough. It's very, very hard. And for these trace minerals especially, it's going to be big buck experiments. We got some USDA or somebody's going to bite the bullet and do some of these isotope experiments so we can determine endogenous fecal versus absorbed fecal. And that when you feed a cow isotopes, and these would be stable isotopes, you're not talking cheap experiments here,
right? Yeah.
And money, he said I think it's got to be USDA money, but they just have to bite the bullet and say we're serious on fine-tuning, improving trace mineral nutrition. We need this data, and it's just going to take. We know how to do it. We've got the methodology, but it's just so expensive for large animals. They've been doing it in humans and rats for a long time, but a cow eats a little more than a rat does.
A little bit, yeah. A little more complicated system too.
Just a bit, yeah. So that is a major thing, and another big problem is there's fewer and fewer people in academia that study minerals.
That's so true. Yeah.
And I'm very concerned that, pretty soon we won't have any expertise in it. And so we need to keep some, we don't need a million people working on it, but we need some in
Right.
academia working on trace nutrients, because they're very different than the macronutrients. So.
Yeah. Is that our biggest bottleneck in general for understanding mineral nutrition? If we think again towards that next NASEM that's
Yeah.
coming out, whenever it comes out, is that going to be the next frontier for mineral nutrition?
I think so. I mean, you sit and look, there's never, and there shouldn't be as much work on minerals as energy and protein, all that. I realize that. But you look at the number of papers being published in minerals, it's pretty small. And a lot of those have to do with hypocalcemia and hypomagnesemia. But there's a lot of other minerals. And you just, on trace minerals, most of the papers now is looking at organic trace mineral versus sulfates. And those have value. I don't want to discourage that, but they don't add a lot to the basic understanding, which is what we need. So I don't know who's going to be, if they do another one of these in 15 years, who's going to do it. I'm assuming by then there'll be some new people in it. But right now, if you had to ask me, they had a committee who's going to be on it for trace minerals, I'd have trouble coming up with too many names.
What's your opinion? This is going to be maybe a very off topic, but not really, because you kind of brought it up just now. What is your take on there's fewer PhDs that go into academia, right? There's a lot of folks going, the industry pulls a lot of folks into it, right? And maybe there's not as many jobs in academia as there used to be. Maybe there's not as many people interested in academic jobs as there used to be. What do you think that the implications are of that?
Again, you can argue that, not every state should have a dairy program. And I agree totally with that. You don't need dairy programs in every state, but you need some. And you need good people, and you need if you're going to have fewer and fewer centers of dairy research, they have to have adequate critical mass. And it concerns me. Just no question on just critical mass and on PhDs that stay in academia. And almost all the PhD students I had went to industry. And I asked them why, and they said one is it's money is important, the salaries are better, and they just thought they'd see most academics actually work pretty hard. People may not agree that, but they work hard and long hours, and a lot of them said, well, I don't want to put in the same hours you put in, it's just too much. So we have to make it a little bit more enticing, and it's salary, it's quality of life. And it is, you're in academia. It's a great life. You work hard, but it's a great job. And we just got to convince these students that, I'd heard too many professors sit and talk to a student and say, oh, I hate my job, blah, blah, blah. And then you don't do that. If you hate your job, go find a new job. But we need to encourage these funds and just tell them all the good things, too, about academic jobs. There's some bad things, but there's a lot of good things, too, about it. It's a fun job.
Yeah, I think that's a good reminder for me. I always try to encourage my grad students, ask them, when's the last time you've taken a day off? When's the last time you've taken a nap?
Exactly.
And they turn the tables on me every once in a while, and I don't like that.
We all need a little life-work balance. Is an issue. So
do as I say, not as I do. Yeah.
It's time for our famous three. Mycotoxins are silent poisons, challenging the health and productivity of your cows. Protect your cows and your business by testing feedstuffs to know which mycotoxins are present in your environment. With that information in hand, you can work with your nutritionist to develop a management program to reduce mycotoxin impacts on your cows and your operation. To get started with your own mycotoxin control program, talk to your Diamond V representative today.
All right. Well, I think probably it's about time for us to go into our three questions that we ask all of our hosts, or all of our guests, sorry. And I'm really curious to hear your perspectives on this. So the first question that we ask all of our guests, again, we were chatting beforehand, you're not legally required to say NASEM for this first question, but you can if you want to. What is your favorite dairy-related book or resource?
It's NASM, and it's been NASM since I was a graduate student.
Yeah.
Just because it's got something on everything, and it's a good place. Great if you're a scientist. It's got great reviews, and it's a good place to start. I'm biased, but I really think if you're in dairy nutrition, you should have that book. Not just the software. You should have that book. It's a great reference.
Yeah. Mine disappears every once in a while. I've got it back there on the shelf next to Van Sost's book.
I have it right here.
There you go.
Even though I'm retired, it's still next to my desk. So
Yeah. Well, it walks away every once in a while, and thankfully it's kept coming back. It hasn't walked away permanently yet, but it's one that when people borrow it, they enjoy it. They get a lot out of it. Yeah. So our second question is your favorite non-dairy related book or resource.
well, it's still dairy related, but Journal Dairy Science, I still get that. I don't read as much as I used to, but I still look at the table of contents every month and read a few papers. I used to read a lot more, so that's a great thing. And I'm actually this JDS Communications. I'm really liking that.
Yeah.
The papers are two or three pages, and JDS articles have turned into books, not scientific papers anymore. So I find myself reading this JDS Communications a whole lot more than JDS. But both
Yeah,
are
no,
very good.
I agree with that. It's and yes, I still love JDS. It's still fantastic journal, in my opinion. But the JDS Communications and the graphical abstracts too, a really well done graphical abstract is really a
I'm
highlight.
glad
Yeah.
I didn't have. I'm not creative enough to do those,
Right. Yeah.
so I'm glad I never had to do any. But
I don't know how much vetting they do of all the graphical abstracts because they're not all very high caliber, but the good ones are really well done. Yeah. Yeah. All right, and our last question that all of our guests get is what do you think sets successful dairy professionals apart from the unsuccessful?
I think it's the same answer. If you ask me anything on that, it's your willingness to learn and
Mm,
to adapt. If you look at my career, it's gone. My research program has changed significantly over time, and so you have to learn new things, and you have to change. If you don't change in a few years, I told my students when they graduated, I said, if you quit reading the journal and quit doing it in 5 years, you'll be obsolete. And you have to keep up and learn new stuff.
everything changes so fast, doesn't it? We're just learning. It feels like we're learning more and we're learning faster all the time.
Exactly. Things change faster and faster. And if you don't keep up, like I said, 5 years, you may be the best in the world. In 5 years, you will be in the middle of the pack. And 5 years after that, you'll be at the bottom. So,
Yeah. I think that's good advice for academics too. We don't always
exactly.
it's really
Exactly.
easy to sit in your ivory tower and pay a lot of attention to your specialization,
So
but not
I
what's
love
going
I
on.
love the extension part of my job because I'd go out and people would tell me what their problems are, what the real problems are, and some I could design research to address. Some I said, well, I can't, but you
Yeah.
always learn stuff, and then you can bring that back to the lab and hopefully do some stuff about
Yeah. I agree. It's 60% of my job is extension, and it's it adds a lot of balance to your teaching and your
it.
research too.
Exactly,
Yeah.
exactly.
All right. Well, Dr. Weiss, thank you so much for joining me today. If folks are interested in learning more about what you've done and any resources, you mentioned, what was it, 450 proceedings and extension articles. If folks want to learn more about some of the work that you've done in your career, where should they go?
Well, I still have most of those. I did a lot of publication in the Tri-State Nutrition Conference, and that's all available online. And those are some really, I'm biased, but I think those are some really good papers, not just by me, but by lots of people. I still have stuff up at the OSU Dairy website. I think it's dairy.osu.edu. There's a lot of little extension articles. All the stuff I've written in JDS is available. I think by now a lot of that is open access and anyone
Hmm.
can get that. And I'm much slower on email. I'll just say that I'm retired. But if someone wants something and they can't find it, and email me, I won't promise I can find it, and I won't get it to you the next day. But some of this stuff I'll try I do try and answer emails and get stuff. Well, still is a really good way to find stuff. So.
Yep. All right. Well, thank you so much again for our conversation this morning. I guess it's morning here. It's afternoon where you are, and who knows where it is, what time it is when folks are listening. So, but thank you so much for joining us, and it was great.
Thank you for the invitation. It was fun.